My name is Ashwin Rao, and I'm a group product manager with the Developer Tools organization. I specifically focus on NetBeans, hence the shirt. The basic agenda for this session is kind of really look at the motivation, and you might ask me, why should anybody talk about motivation, right? But I do want to come back to that and kind of talk a little bit about maybe what kind of processes and best practices we should be looking at, and kind of review some of the features. Now, I'm going to show you some things in NetBeans, but I will clearly state that it's my intent for this particular session is kind of to see if we can engage with, provide my perspective on this, and perhaps look to see if you folks can really pick some things up, use other tools to kind of accomplish delivering better code. So that's kind of the overall nature of the agenda. And the preamble I kind of want to give is really this. I first proposed this topic for a conference in India, and I wasn't too sure whether this would be kind of accepted. Most of the sessions were about the latest and greatest, what's cool and things of that sort. And it's like, hey, write bug-free code. And let me see, how many of you actually think you can write bug-free code? Thank you. So that's the first thing. It's not the intent is not really about, hey, can I deliver bug-free code? But it's getting into the mindset that you want to deliver bug-free code. All right. So let's get that clear. There is no magic bullet. There is no big red button that I can provide in the tool saying, bang, no, make sure that I don't have any, bugs. So I was a little nervous whether it's going to be accepted. It did get accepted. They put us, I was quite happy about that. At the conference, I got into a room. It was a relatively smaller room because all the big rooms were given to the sessions that were like the in things. And I was surprised. I was surprised because a hell of a lot of people trying to get in, kind of like today. And that made me really nervous. I was like, oh boy, what's the expectation here, right? I mean, I hope they're not expecting that I'm going to reveal something magical. And kind of started it off, and I said what I just said, and I expected a few people to leave. So if you're looking for a magic bullet, there is no magic bullet, all right? So let's make that really clear up front in this thing. But the session went well, and in fact, a lot of people came and said they had certain perspectives about it, and I said, okay, that's pretty good. So I got the session, basically submitted it over here, and here we are. So that's a bit of the preamble to it. The other thing is, I just thought I'd kind of talk a little bit about, why would you want to listen to me? I'm here to provide a perspective because I started my career in the defense industry. How many of you are with the defense already? There are a few folks here, okay. And from the standpoint of the defense industry, when I got in directly from college, and it's like, okay, you're up, you learn C, C++, and by the way, I started working on an ADA project. Any ADA programmers here? Okay, that's great. So I started with that, and it very soon became very clear. The focus and the way we were kind of working towards, delivering a project was all about zero defects. I mean, I was writing code for the command and control system for a naval frigate, really. So the machine subsystem that I was working on is a close-in weapon system, something that shoots down missiles. And pretty much, you don't want to have defects come up when a missile is coming at you at Mach 2, right? So it was that complex. And the whole process was very long drawn. I mean, if that particular project, the design phase itself ran in a couple of years, right? So you started doing a lot of little bit of prototyping per se, but it's mostly design, kind of level prototyping. And you got into the coding cycles, and it was relatively short compared to the years of design and the requirements phase before that went into it. And then you have these huge testing cycles. So the whole concept was, you wanted to make sure, absolutely sure, that you could, to the best of your ability, figure out whether this particular software has no defects. I mean, again, zero defects, I don't think anybody can claim that. But close to zero, yes, that was the intent. And so the mindset was delivered towards that. So that's how I started my career. And quite frankly, when I switched a few years later, and then I got into the commercial side. I was with the R&D organization for Barn, which is an ERP company. It's kind of gone away. And I started working. I was like, wow, this is pretty cool. I mean, I can start coding. You know, I get requirements. I can start prototyping, and I can start delivering code. That's great. And I was pretty intent. And then I moved into product management for a few years, and then I started working product teams. And the whole concept is different, right? It's time to market. Nobody can wait for 4 or 5 years, and to kind of deliver something. Somebody else will come to the market and deliver it already if you want efficient code. Return on investment is key. And generally, compared to my previous background, the kind of longer coding cycles, interspersed with the testing, it was all kind of going hand in hand to some extent. Very short design cycles. Right? There was hardly much design actually being done or vetted. Maybe design is being done, but actually vetted. And that was interesting. I found that actually a kind of like got a lot more freedom on my hand, and I was like quite happy with that. But over the course of time, I've actually noticed quite a few things that really made me question whether that's kind of right. I mean, we have a lot of tools now trying to accommodate this, and there's agile and there's pair programming and all of these things. You do sprints and so on and so forth, and that's fantastic for time to market. But there are a few things that I started questioning as to the validity of these choices. Projects that I've been involved with, projects that I know of, you take decisions. You look at some of the code that's been written 2 years ago, and all of a sudden people have left. The code is there, it's got some bugs in it, people don't know what it is, and we've been taking decisions. You know what? The cost of actually maintaining that code is far greater. And rather than probably rewriting it or dropping that support completely, there are motivations to drop support just because the code was not maintainable. There are a lot of bugs which shouldn't have been there in the first place. And so I started looking back and saying, is this the right approach? And fundamentally for me, I think there is a middle ground. And that's my perspective. So one of the things that I wanted to talk about was really about, hey, can we get back to the basics? There are certain things you can do, and it doesn't necessarily mean it has to come in the way of some of the newer techniques and the newer philosophies for developing code. So that's pretty much my background. It's about 15 years. I started in the early 90s, and so spanned from the defense to a totally different world to the pendulum swung, and I'm just wondering whether there's a middle ground. And that's the perspective that I want to provide. And there are certain tools that help us. And that's the other aspect of it. So you go through the process, we look at the tools, and the tools are there. And I was really asking these questions. Are we using these tools, including in our own organization? And the answer was no. And I'm like, why? And so we can have a look at a bit of that as well. There's many ways to do it. I've just put a very simplistic thing. So what is smart and efficient code, really? So people I ask, people say, hey, has to consume optimal resources. You don't want your code to be hogging up all the resource. That's fine. Performance, you want the performance. That's kind of key for everybody, right? Easy to maintain. That is kind of an afterthought in many cases. Easy to maintain is one of the things that I think is lost in all of the kind of processes that we look at these days. When you write your code up front, the focus is on how well you do it and how quickly you can deliver it, the features it meets. But not a lot of thought goes into, will this code be easy to maintain? And we look a little bit about what essentially does that mean, and whether are there tools or is it a best practice that can work? And really, yes, the point is you've got to focus on delivering software that has no bugs. That should be your focus. If you go in thinking, bugs are fine, we can handle it later, that's probably not the best concept. Now, even when you go into the focus, you're always going to have bugs, all right? So there is nothing like bug-free code, but you can minimize it. All right, so just a bit of history. Anybody here in terms of why do we call a software defect a bug? Thank you very much. The answer was the original machines actually had bugs. So this is an interesting one. The term bug was coined by Grace Hopper, and it's essentially because there was a moth in the original machines. These are mechanical machines. There's actually moth that was found, right? And that caused a defect. And so there's this photograph, and it's actually on the Wikipedia, of the actual first bug. All right? So that's how the term bug came into effect. It's a software defect. Now, I must admit, it's been, it was a few years after I was into software that I actually caught on to this. Somebody mentioned this to me, and I was like, oh, that's interesting. I never really questioned why we call it a bug. So that was how it was. Basically, the first defect was introduced via a bug. Generally, where would you think you can actually introduce defects? It's important to kind of understand this, because I think the motivation for getting into this bug-free mode, it kind of lies in over here. A lot of bugs can actually get in during the specification, kind of the requirements gathering phase itself. And when we say that, it means is, okay, you have a basic basic requirement for providing a solution. And you may not be thinking of all the corner cases. And when you look at those, and when you don't provide those requirements, and you provide a solution, and somebody gets into a particular situation, from a consumer perspective or the end user perspective, it could be a defect, because it's not a defect is not necessarily something going crashing on your system. It's maybe not being able to handle a situation it should have handled in the first place. Now, when you're trying to fix it, there's going to be solution, and we'll have a look at that. So, the design specification, there are bugs introduced. What about coding? That's obvious. Any idea why data entry is in here? Well, I'm not saying I have any idea what happened with your Apple Maps stuff. How many of you have issues with Apple Maps in iPhone 5, right? There are lots of people complaining about it. I don't have an iPhone 5. I don't know whether there are issues. It looked pretty cool to me when I saw it. But I've been reading some of the feedback. A lot of it has to do with some, data not missing. And that's kind of one example of, hey, data actually providing, actual end user defects that people log as bugs. So, of course, there are algorithms they say that is kind of not good. Somebody says, hey, you know what, that Google Maps routes me better. But sometimes the data itself is wrong. You say, hey, wait a minute, my street is not there. It's not named, or something of that sort. So, the fact that data can also cause bugs is also an interesting thing that people don't keep in mind. And certainly documentation as well. If you got wrong documentation, it leads to perhaps it leads to your end users doing something wrong, and then that causes defects, and it could cause defects in how your software reacts to those wrong inputs. So it's not just coding. It's predominantly, in my opinion, requirements and design phase, predominantly. A lot of it is introduced because of coding as well. And data is kind of an interesting combination. And again, I have no insight into what happened with Apple Maps. I'm just assuming that I might be off base completely, but I think it's a good example of perhaps data being a cause of a defect being introduced. So from that standpoint, this is another interesting aspect that organizations and teams don't really focus on. And I tell you why, because when I started my career, this was the first sessions we had with the team. When we got into the project, it's like, okay, the bean counters came along and said, you know what, here's what happens when you guys don't do your job properly. Interestingly, when I got into the commercial software space, nobody really talked about it. When I started looking to see if there's any actual essential data that's available regarding cost of fixing a defect, bugs, or defects, there's not much newer data coming through. People are not necessarily collating it. So what technically happens in the requirements of design, when you catch a bug over there, essentially what it means is when you think of certain things that could go wrong and you figure out that's a requirement that your software has to address, there are not very few people involved. That's basically you're an architect, they've got it, right? There's not much happening. And the cost is minimized to that time. It's not, it's not rolled in. The development teams are not involved. And as you move forward, when you start coding, yes, it gets a little more cost intensive. You've got your development teams now involved, but it's still the developer in question who potentially can fix some things if it's caught there. So you're literally, the cost of fixing a defect is relatively low. The idea being that your extended team is not involved. When you move into integration, there are problems, because now people are perhaps dependent on what you've delivered, and things go wrong. Other people are involved. There's more time involved. More of the team is involved, and that's an issue. I mean, look, we have continuous integration and things of that sort. Hudson, and I see this even in our own teams, and it's a conversation I tend to have, and I try to have. Is all of a sudden somebody, a developer sends in and says, hey, wait a minute, I've just made these changes to these APIs. Can anybody tell me who's affected? All right, okay, this is in the trunk, it's gone into the integration mode, and then all of a sudden, 6 people said, you know what, I've got to redo this stuff because your API has changed. Yes, we have refactoring tools. Yes, it does your job quicker. But about 60 to 70% of the time, some of those API changes need not have happened if you had thought of the design earlier on. And that's an important aspect that, that needs to be addressed. It's going to minimize the costs of addressing these changes. And when you go to testing, it's even more. Now you've got QA involved. You've got an actual process that needs to get into place. Bugs have to be filed, to be dealt with. QA has got to look at it. And that's resource intensive. So it really concerns me when teams, are pretty much going in this full steam ahead mode without necessarily giving a little bit of input. And once again, I'm not advocating getting back to the 90s or the defense. I just feel the pendulum can come down a little bit. And that's the concept over here. So I think it's kind of self-explanatory. When you go to deployment, who's involved now? It's your customer base. And my theory is once a defect comes into this, it's probably hardly going to be addressed. Just kidding. It depends on support and things of that sort. And there's a hell of a lot of cost involved as well. Now somebody can actually give me another perspective to it. Maybe a lot of people make money because if you don't have defects, you don't get support contracts. Fair enough, but I think you don't want to take a gamble on your software being considered buggy, right? So that's an important thing. So, as I said, we had a lot of bean counters giving us data back in the 90s. The dedicated teams that were reviewing it. I don't know how many of you would find this relatively old information. Now, this is something that's on the web. As I said, I just borrowed that. It's from Barry Boehm, given in 2007. Quite frankly, there's not too much newer data. Our own teams don't really collate this kind of data. But this is very, very close to what I had experienced or what we had to go through in the 90s. If you look at the cost of fixing a defect beyond the coding stage, things start really jumping up. And that's an aspect, as if you're leading a team, I think it will be great to start looking at these metrics. Because that's probably going to help in the end for you to provide better code. So that's kind of the motivation, right? As I said, maybe the first question is, why would anybody talk about motivation in fixing, writing better code? It's obvious. But to me, I make the case it's not really that obvious because people don't really spend that much time earlier on. And the motivation should be the last slide over there. Now the challenge is when you're pretty relatively new to the industry, that's probably not something that you're going to be tracking. It's probably going to be your development teams and so on and so forth. And that's an important aspect. But I think you can make a better case for yourself as you move up through your career in producing a process and getting involved and making it a habit. And that would be much more productive for the team as well as you. All right, so when you start talking about preventing bugs, okay, this is kind of the place wherein people would probably think, is there a magic bullet? I guess I said no, but I would probably want to change it now to say, you know what, there is. It's actually you, to a large extent, right? That it's not a tool. It's you, because as much as we like to write good code, very clever code, and for me, clever is not the same as good code. You got these particular things to keep in mind. There's programming styles, programming techniques that can help. Now, if you look at programming style, what makes programming, what are the important factors to keep in mind? The very fact, if you want to make code readable, goes a long way in reducing defects. Why? Well, when you do a code audit, it's easier for somebody to figure out what's going wrong in your code. And that's an important aspect, doing code audits. How many of you don't do code audits, if you weren't willing to share? Great, okay, so everybody is doing code audits. The point is, it's easier when you write code that's readable. In fact, I actually did, one of the things I liked about Ada was it forced you to be more descriptive when you're writing code. Variable names need to make sense, It's not X, Y, and Z. It's always about, tracks, targets, and things of that sort, as in the defense industry kind of going on, and you write code. Now, what is defensive programming? Now, it's actually an approach that basically allows you to kind of minimize code by making it readable, but also from the standpoint of understanding whenever you start doing something in your process, in your functions, to think of complete end cases, So if I'm looking at writing something that's, literally taking in an input which has an actual limit on the string length or something as simple as that, your defensive programming aspects of it is really looking to see, hey, what happens if I hit that limit? Is it an issue? Can I put in a test to see what happens when that happens? A lot of the denial of service kind of attacks and all of that stuff, the code injection, actually happens because people are not taking defensive programming techniques seriously. And that's an important aspect. We have hell of a lot of denial of service, hell of a lot of code injections kind of things happening. And it's basic. When you boil down to the end problem, most of the time it's because that code got in because nobody put in those checks. Using certain assertions is kind of part of this defensive programming techniques. You do that, you'll be able to minimize a lot more of that, of these issues. So that's the style, sorry. And when you talk about programming techniques, kind of interchangeable. The other aspect is trying to make sure that your code is kind of self-monitoring, in the sense, the assertions, putting in a lot more assertions into your code, saying, I've got this variable, I want to see what happens when it hits its max, or, a particular use case and scenarios. Unit testing at that level should be in the developer's control, and pretty much looking at defensive programming techniques. It's going to add some time, yes, but it still is much more worthwhile across the life cycle of the project. So that's pretty much the defensive techniques. The other things that you can think of are development methodologies. There's lots of it. This is not really going deep diving into it. And there's language support, right? I mean, as I said, Ada, for instance, wanted to make if you look at some of the Strawman documents in the MIL standards for Ada, which, by the way, Java kind of, if you look at the history of Java, it's leveraged a lot of some of the design work that's gone into the language. And that pretty much was to make the language readable. Now, so you got these kind of programming language kind of support. One example is not to support pointers in Java. That's kind of done with this particular aspect in mind. And then there are things like you can do with code analysis. Inspects the code for errors beyond what the compiler catches. So, these are things that you could look at pretty much immediately. And this is where tools can help. Now, the other thing for me was there are tools, there are free tools in the market. Are people using it? A lot of the time I see, everybody's using, they're very, very keen about an IDE. There are the IDE wars, as we call it. There's NetBeans, Eclipse, IntelliJ, all good products, certainly in their specific areas of influence. And many of them have these tools. But a lot of the time, it's all about the code editor. That's great. The code editor is very, very useful, no doubt about it. But there are things that you can use to start helping you with these techniques. To figuring out if your code is actually efficient, static analysis tools, right? How many of you use find bugs? Excellent. Now, with this approach, it's much easier to catch a lot of these defects, and we kind of look at a little bit of what find bugs does in a minute, for those of you who have not used it. And also being able to kind of make sure that your code at unit level is delivering efficient code. Use the profiling tools available. I'm not talking about system level massive profilers and things of that sort. That's different. You need those. You still need the system level testing and all of that happening. But you can certainly run your own software very quickly through a profiler and figure out what's going on before you actually check it in or integrate it. Visual VM is something that is pretty good. Now, from that standpoint, I personally believe when you put that all into an editor and you have an editing environment that does it, leverage it, right? So bring it all together in an IDE. And so that's kind of where we jump into the IDE specific aspect. But I do want to leave this open, contrary to what I represent. It's not about just NetBeans. It's about tools, other tools in the market that have these features. Leverage it, right? So find bugs, right? What it essentially does, as many people already are aware, it identifies potential bugs in many categories. There are different kinds of categories, and we'll have a look at it. And what we've done in 7.2 is essentially make it easier to use it within the workflow that you're already familiar with, rather than switching off and doing it again and things like that. There are merits to kind of generating reports. We want to take this further. There are ideas around it. But it's really to get that workflow so easy that there shouldn't be an excuse for not having done it. And that's the intent. So FindBug, we haven't done anything clever ourselves. It's FindBugs. It's an open source, this thing, it's from the University of Maryland. It's an excellent product, I think. And all we've done is made it more accessible. Now, if you look at FindBugs, as I said, it's open source. There are lots of things it tries to find. Bad practice, it's a category, correctness, internationalization, malicious code. I'm just reading off the list over here. But the most important thing are a lot of the performance and the security aspects of FindBugs, or any other static analysis tools that you're going to use. A hell of a lot of things can be caught right there, even before you get to the profiling stage. And I like the category term they use, dodgy code. That's interesting, dodgy code. Yeah. Don't know exactly what it's going to do, right? We don't know. This sounds different. Method ignores return value. Is this okay? So when you pass that through, you kind of catch a lot of things even before you get to the profiling stage. Now, what we've also had in NetBeans for a very long time is a profiler. And the same profiler is essentially what you can actually see. It's part of the Java JDK, as part of the Visual VM offering. Again, there are other tools in the market that have similar capability tools. So what do you get from these? You should be able to quickly, as I said, run even at unit testing, quickly take it through and do a CPU profiling, for instance, or a memory profiling. You want to see how, where are the bottlenecks, right? Just go have a look and see what happens when you're running your program. Look at the heap and see how many instances, how many classes, variables are there. And you would find a lot of the time that you're looking at it, wait a minute, why is there so many, arrays of strings? Why is that? Is it required at this point of time? That's taking too much memory. What can I do? And guess what? A lot of the time, it's actually perhaps a better design that can address it. And if you caught it at this time, you can probably change the design pretty it's still going to cost because it might affect the other teams, but it's not necessarily as advanced in this stage as in when you would find once the product's in testing or with the customer. And so this is a kind of key thing from that standpoint, is to understand that these tools are there and it has to be leveraged. So what I want to kind of switch now is to probably run through some things we've done in NetBeans IDE. I talked about profiling, I talked about find bugs, and I've talked about profiling. And it's as simple, it's a simple thing to kind of think of, the concept of what it needs to happen, but I don't believe it happens often enough. All right, how many of you are NetBeans users at this point of time? Okay. How many of you actually used find bugs with NetBeans? Kind of dropped down there. I mean, for me, that itself is an indication that it can improve. And I really don't believe there's any kind of actual software that's out there that is completely, free of bugs that find bugs won't catch. Now, I actually wanted to pick up and put Gertjan on the spot. Gertjan's in the audience over here. There's one of his find bugs demos that he's done where he's profiled his own project, and he caught a lot of errors that he was a bit surprised of himself. And then I realized that particular project required JavaFX, which I'm an older version of it now, so I dropped that. So this is going to be a little bit more in terms of showing you the capabilities rather than really proving what kind of benefits there are. So I've got an anagram game or a simple game. This is just one of these examples that we have, and to some extent I could go to source and do an inspect. When you do that, as I said, this is for us, it's one of the start of providing these kind of tools, right? We would like to kind of start looking at more of these kind of capabilities. So fundamentally, you can actually do your introspection across the project or across all open projects, and sometimes even at the file level. So that's something that you can choose. And you can actually look at what you want to do. So Findbugs has got to separate these things, and I just do an inspect at this point of time. So it's now going to look at the code. The code is extremely small. It's probably going to have a couple of errors if I remember correctly, or reports. It's not necessarily an error per se. And then I get this view over here. When I expand it, it's got some information that I can look at. There are two errors, one really, and it gives me some details. This is directly from the Findbugs documentation, non-transient, non-serializable instance field in serializable class. And if I double click it, I should go back to the code right there. Now it starts the process of introspection already. In fact, the code editor is actually going to be giving you these kind of hints right when you're editing. So perhaps that's a good thing to take a look at it, but Findbugs also catches it. I've got another view that, with Findbugs that also is easy to kind of look at, and this is by category. So now I want to figure out how much of it is dodgy code, how much is bad practice, and if there were security type of examples, that would come up here, and you can then start drilling down and looking at exactly where this particular thing is. So this is a simple example of using Findbugs, and it doesn't take you more than 2 minutes to do this. But it's probably going to save you hours of rework if you had some real issues here. All right, so that's a quick example there. The second thing is, okay, once you've gone through the coding phase, we wanted to have a look at, all right, what exactly would be the capabilities that you can do with the profiler, right? All right, so to do that, we've got a profile window here. And I just start the profile project. Immediately, I've given a few options. I can do CPU profiling, memory profiling, and you can select these. You can customize the things that you want. And if I select CPU, for instance, I can do a quick one or an advanced one with a little bit more instrumented, and profile any project classes or profile all classes that the project depends on. So you can choose what you would like to see. typically would like to see just the project classes. I've got to look at it, and I said, all right, this looks good. I'll just do a quick simple run, do a run. And it starts the actual app. Now, what I'll do is I'll switch on the telemetry view, and here it's starting to give me a live view of what's happening with respect to the heap size, the used heap, some of the other thread information, and so on and so forth, the loaded classes. And that's already started giving me that view. What I could do now is, look at a few things. I could look at the live results. And now it's giving me information about, okay, hold on a minute. This is more information about exactly which classes and what objects, where in the program, the bottlenecks are. The time taken in anagrams, initialization, main. These are relatively simple, but it gives you that concept. And I've got this live view. I could save this, or I could take a snapshot at this time. And the snapshot now gives me a lot more information. It gives me the call tree and tells me exactly where all the time spent is. I can figure out, okay, what calls are causing some issues over here. I'm looking at main, at the anagrams, get install, look and feel. And it's kind of taking me to the code, which is essentially where I can start seeing why is that so much time taken. Probably there's a call to set look and feel, and that's not that bad. So I'm already getting a bit of a sense for it. There's also hotspots, right? So it's again telling me which exact method has these issues over there. This particular software is very simple in nature, so it's not necessarily telling me there's any big problem, but I could start figuring it out. And I could go to source, show back traces, find in call tree, and so on and so forth. So this is kind of the back trace for that. So that's one example. If I look at it, I could also get a combined view. If you're on a bigger monitor, it's easier to see. I've got to kind of address it to this particular resolution, so there's lots of information there. And there's an info wherein I could actually save this information for later usage. Edit, and put some comments in, send it to somebody to have a look at, so on and so forth. I could even dump the heap now, kind of. It's the profile project, choose, okay. And the heap has been successfully saved to a file. It's asking me whether I want to open it in the heap walker, right? So I could now choose to say yes. Open it in the heap walker. And I've got some summary information about what's in here. Total bytes, total classes, total instances. It's quite a lot of it already. I can have a class view over it. I can look and say, there are lots of hash table, strings over here, show an instance view. And it tells me all the instances of that particular class. Right? Now that I've got the information over here, I can look at it and see, is there a reason why I have to have so many instances of this class, and so on and so forth. Again, genuinely, if there's larger projects, large-scale projects, you could have more of these challenges right away. And this can be done at your unit testing level to some extent if you have some example data, or if you're going to use just some sample data for yourself. You could also inspect it, and I'm not very familiar with object query languages, but you could also do your own kind of queries on this particular heap. So you can do a lot more. You can get more information from this, just to make sure that your design, your implementation of a design is correct. So that's a quick example. I didn't really, as I start running this app, it could probably start doing more interesting things, but I'm not necessarily trying to load up the app over here. But you can actually do some amount of load testing as well. You start putting in a lot more entries into it. You can actually perhaps write some scripts to load up your app. And then see what does it do when the load starts increasing. It's a little more involved, but I think it's useful. So that's a quick look at it. I could stop the profiling session now. Just look at what you might get with the memory profiling at this time. So for that, I could restart. Oh, no, I want to stop this, sorry. Go back to the projects and profile, project, and this time I'm going to choose memory. So similar kind of stuff, but a different kind of data points. You're now looking at exact memory usage, classes, objects, instances, and things of that sort. And you run it. And I get, again, start looking at the view. I got the telemetry view, which you're familiar with. I could take the live results, and this time it's kind of showing me, okay, how many bytes are being used, where is the most kind of allocations happening. There's an int array. I can go to source. Now, there's a primitive array. Yeah. So again, you can start looking at it, if it's something that's pertinent to your class per se. Take a snapshot. The snapshot provides similar information than live, but gives you more info that you can save the snapshot, reuse the snapshot, and things of that sort. So, by adopting these tools, not necessarily NetBeans, but I'll be more than happy to hear feedback if you use NetBeans, you're going to be influencing the quality of your product and the delivery of a really better solution much earlier in the life cycle, costing much less. There are other things that you could do with that, but probably things that you can look at. And by no means is this a case for not doing profiling at the system level. That needs to happen. That obviously does happen in most of the other projects that you work on. All right, so those are the tools, but particularly that's there in 7.2. Predominantly to help you write better code and profile your applications. And so, what is it that we can actually look at? For me, it's actually a very simple thing. I did lose a bullet, did I? Okay. A defect already. I should have probably tested that one. It's very simple. Bug-free code should be your goal. Whether you deliver a bug-free code, that's a different issue. Nobody can deliver bug-free code. But you can minimize the amount of bugs by practices that you employ. This is for the Java platform or elsewhere. Apply a bit more process. There are tools that are available for free. Leverage them. If you do this, I can assure you there'll be a lot less that you have to worry about when you start delivering the solution set. And it's all it takes, in my opinion, to provide that. Tools are not the answer, it's actually you. Because you've got to actually A, employ the right process, and B, use these tools. So that's pretty much it from the standpoint of what my perspective is on this particular subject. And I hope there's some takeaway to it and maybe at least causes a discussion of sorts. Thank you.